now we're going to move on to how the homogeneity of populations is different. So this is going to compare two different groups where we have two samples. So Drew, are you listening? All right. So we're going to use a two-way table for these. Two-way table. We're going to compare two groups, and it could be in parentheses or more. Two or more groups, yeah. And this test is going to compare to see, are those two groups significantly different from one another? So in the first, listen up guys, in the first example we had one sample of 300 that was divided up into different different subgroups, okay? And now each subgroup was counted up, and we tested to see if that proportion of subgroups changed in another sample. So whether or not they fit what we expected. In this one, we're going to have two separate samples, and we want to compare the samples to see, is there evidence that suggests the two samples are different. Now, these two-way tables will be rows by columns, a certain number of rows by columns, and the degrees of freedom here. Do you remember what that would be? Any responses? Okay. The rows minus 1 times columns minus 1. That's right. Another part of this is that when we want to calculate expected values, there's something that we use along with rows and columns. Do you remember what that was? All right. The expected count has something to do with the rows and the columns. Do we remember what that is? Fantastic. Good job, Kiara, to call her out. So that's right. The row total times the column total. So whatever the total is in each row and column for that entry is multiplied together, and then we have the table total is what's divided. And we would have to calculate that for each entry in our table. So for example, if we have 3 rows and 2 columns, we'll have 6 entries, and each of those 6 entries we will have to calculate an expected row and column value. All right. Row total times column total, as Drew asked here just a moment ago, divided by the table total is how we find the expected values in each one. And we're going to look at an example for this. This is going to be on page 749, I believe. Look at the back of your book. Or not your back of your book, your back of your paper. Homogeneity of populations. Right? Homo meaning the same. So are the populations the same? That's what homogeneity is asking. And it generally takes this form. H naught is that all proportions are equal. HA is that not all of them are equal. We don't know which ones are different. We've got the summary here in the two-way table. R minus 1 times C minus 1 is our degrees of freedom. And our expected count is equal to, there should be no summation right there, so make sure you mark that out. That's a mistake. Because I forgot, Drew asked, why do we just write all this? Because I forgot I put it on the back. So we're going to look at problem 13.14. It's on page 748 and 749. So go ahead and set up your table with the data.